Hello everyone, welcome to Step Logic. First, let me explain a little bit about sequence control. This is a very common type of automation control system. In this type of system, first there will be something happen or called event, and that will trigger some actions from your system. Then after that, there are other triggers, there are other events follow that, and then consequently there will be different actions to take because of that. Alright, so that's the sequence control. I choose the word of structured. Is that the reason is that I want to find a way with a fixed unified style to design the ladder logic. Right. Mainly that we want to establish the steps first. Then we will control the system output with all the steps. Right. Let's get into that details. At first part, I give you the formula. It's like a general format. All right. So in the ladder logic, we will have the different steps represented by the over here step n. So that means the at the any of the step, current step. So in order to have this step established, you need to have the previous step. This is represent n subtract 1 is the previous step. After that, you will have a trigger for this particular step. Right. And after these two conditions, you will create energize a step here, and this step come back will bypass the trigger. So the trigger really only need at the beginning. So after that, it will be bypassed by the output. Right? That's what we call seal in. So this is the first part to establish the step. Then the second part, we want to use the steps to control the output. So for all the output, there will be two conditions. One is the step to turn it on. And then we will follow that by exam off, the step to turn it off. Alright, so this is the first format I want to introduce. So there are two different parts. And then let's look at an example. So over here I gave you a three steps in the logic. Alright, so for example over here we have step 1, step 2, and step 3. And how do we apply the formula? Let's look at here. So in order to energize the step 1, we need to have the previous step. But because this is the first one, we don't have a previous one. So then we will just use the exam off of the last step. Right? We have 3 steps. So step 3, exam off. That will be the previous step. Then you have a specific trigger for the step 1. So this is the first run. On the second run, you want to energize step 2. That will be the typical the formula, right? Step 2 have to have the step 1 complete. Then whatever the condition to start step 2 will be examined after that, and then similar to step 1, we will have a seal in to bypass the trigger. So when we get into the last step, obviously we still need previous step, which is step 2. It has its own trigger and similar bypass. Right. But this bypass is really optional for the last step. You will see what I mean, why it is the optional. Then this is what we have for the second part. All right. Second part is just for example. If I have 2 output, then we will have the step to turn it on, step to turn it off. Right. So that will be the same thing for output 2. With output, it's more specific, right? Not really follow the what I gave you here. So we will have to look at the specific output. Right? Let's go back to the first part. That's more important to understand what's going on with step logic. So suppose we have all the sequence go as planned. Once we reach to step 3, which is the last step for this control, and then let's see what happened. With step 3 energized, and after that, for the next scan, program will start to scan the run number 1 on here. And step 3 is already energized. The instruction exam off will give the logic false. With logic false, step 1 will be de-energized. With step 1 de-energized, and on here will become false again. And after that, step 2 will be de-energized. With step 2 de-energized, that will affect step 3. So step 3 will be de-energized as well. So that is what happened when you reach to the end of step. Right? Once you reach there, the very next PLC scan will clear out all the steps, right, ready to restart again. So this is very important. All right. Over here, there's another one I input over here. I put over here is called reset. This is like a reset branch for troubleshoot. This is like a troubleshooting backdoor. So when you're working on the step logic, sometimes the program is stuck in the middle. Right? When that happens, you can just manually come back here to toggle this bit. When this bit being toggled, the end step 3 will be energized. And then if you remember, I just talked about that. With step 3 energized, all the steps will be cleared. So basically, you reset your logic from scratch. The next slide, basically I already talked about all this. If you want, you can read this slide by yourself. Right? You just basically repeat what I just talked about. Yeah, I think I covered all this. Then let's look at the timing diagram. This is more important for you to understand. The example I just showed you, we have 3 steps and 3 triggers. Right? So this is triggers, this is steps. So you can see here with trigger 1, you energize step 1. Step 2, step 3, not energized. And follow that, whenever the trigger 2 become true, that will establish step 2. Right? Notice here step 1 is still energized. Right? And then at this moment, step 2 will be also energized. And follow that will be trigger 3 on here at this moment. That will eventually energize the step 3. And over here is the part I explained for the reset process. The very next PLC scan will start clear out all the steps. At the bottom here, I include 2 output. Again, we'll wait for the specific example to talk about how do we set up the output. Right. So for now, for this one, you can just see we want to turn on output 1 when the step 1 turn on. You can see here that follow the step 1. Then when step 2 happened, when step 2 start, and then you will turn off this output number 1. And in the same time, your output number 2 should become true. And output number 2 will be clear out at the step 3. So this is just an example. Right? Okay, so now let's talk about a specific example. So we'll just use a very simple system, push button and pilot light. So we have 4 push buttons, PB1 to PB4. So they are different type. Normally open, normally close, normally close, normally open. Right? That's the same setup as the one we use in the lab. And the last trigger is a select switch SS. Okay. So PB1 will start the step 1. So when we press PB1, step 1 established. Then we want energize PL1 start from the step 1, but not all the others, not the other 3 PLs. And step 1 PL1 will be energized until the end, right? The step 4 here. So step 5 will clear out everything, go back to 0. And similar to that, PL2 will turn on from step 2, and PL3 will turn on start from step 3, and PL4 from step 4. Right? So it's just a simple example on here. Then let's follow the formula as before, right? So as this formula will establish 5 steps. Let's look at here. So we have step 1 all the way to step 5. With step 1, we use step 5 and PB1, and that's the trigger. When you press normally open push button, you use exam on to get logic true. And trigger 2 is normally close, right? So when you press normally close push button, you have to use exam off to get logic true. So and so on, so forth, right? So that's the part we establish all the steps. And then over here, that's the reset. Notice here, just if you didn't realize, I use the UDT to include all the steps, right? So you can see S dot, S dot. So they all represent by a UDT tag. Okay, that's the first part for the steps. Then second part, how do we energize the output for the PLs? So you can see here with PL1 energized from step 1. So that's the step to turn it on. They all turn off at step 5. So that's why the second part, exam off, step 5. But they turn on different step, right? So for example, step 2 turn on the PL2, and PL3 is turned on by step 3. So that's how we translate the general formula into the real ladder logic. On this slide, I gave you the other solutions, right? So you may think, okay, this is the step logic, but I can do the exactly same result without step logic, right? So that's over here. Look at here. If I use seal in, so that's the solution. You can look at here on this. All right. So that's different design. All right. Or you can even use large and large. That's the result. Right. If it's large and large, it's even looks like easier, simpler. Right. But the point I'm trying to make is here. The step logic provides some advantages. First, it's a structured design. Right. You will see with different design, if you use the seal in or output large and large, you will have to adjust your design to different variations. But with step logic, it's very easy to modify the design for the complex variations. So I can give you examples on the next slide. So on this slide, I present two of the different sequence. All right. So with this sequence, you can see here PL1 only turn on with the step 1. Right. Will turn off from step 2. And same thing for PL2, it only turn on for one particular steps. So with this type of requirement, if you design with the seal in or the large and large, you will have to make a big structure change. But if you have the step logic established, you only need to make change on the output. So over here, you can see follow this, I only list the output part. The step part, we don't have to change. It's exactly the same as this, step 1 to step 5. But we only need to change the output. Instead of step 5 on here, we just change that according to the requirement. Right? PL1 turn on from step 1, then turn off from step 2. PL2 turn on from step 2 and turn off from step 3, and so on here. Right? So this is one thing I want to point out. For the other example, you will see more complex example. So from this chart, you can see we need to energize different output on different time according to the chart. For example, PL1 should be energized by 2 different steps, and then PL2 will have 3-step turn on in the middle, and PL3, PL4 has different requirement. Right? So it's rather complicated output. But with the step logic formula, again, we don't need to make any change on the steps. We just need to come to the second part on the output, because PL1 should be energized by 2 different situations. We have 2 branches. So step 1, turn it on. Step 2, turn it off. And step 3, turn back on. Step 4, turn it off. So that's exactly match up on here. And same thing for the PL2, because we want to turn on PL2 from step 2, and then we will keep it until the end step 5. So that's why we want step 2 energize it, step 5 de-energize it. With same thing with PL3, we have 2 scenarios, so 2 separate branches. Right? This is on, this is off. Right? So you can trace this to understand how do we set it up. Right? So I want to design to demonstrate the result right now. Okay, so this is what we have for the PB and PL. Let me see the logic. Okay, let me start from the beginning. I should demonstrate at the beginning, but it's okay. We can just start from here. So this will be the first step logic I introduce. Let me see here. Step logic intro. Okay. So if you look at this, that's the design with the slide on here. Let me look at here. That's this one. All right. That's this program on here. Yeah, I'll just choose on here. Alright, first we need press PB1. Right, so that's the trigger number 1, step 1. Right, press PB1, PL1 to turn on. That's what you see, PL1. And all the other 3 are not on. Right, so for the next step, step 2, you have to press PB2, which is here. Then you can move on to turn on PL2. But if you press other buttons, right, that won't happen. Even you press PB1, nothing happen, right? So you have to press PB2 because it's waiting for PB2 here. So PB2, then turn on PL2. So you have both PL turn on here. So followed by that, same thing. You have to press PB3 to turn on PL3. Then PB4 to turn on PL4. So you have reached to the end. Alright, so let's look at the logic on here. Let me make it bigger a little here. Okay, so you can see here all the steps being established from 1 to 4 right now. And now it's just waiting for SS to go into step 3, which is the end. right? The end of the steps. So you have all the output turn on, right? So the trigger for step 5 is the SS. So let's go back to the select switch. Select switch SS is here. So when I close it, that's become true. Then go back to the next scan, clear out all the steps. You will see all the steps will be de-energized. So I will turn it on and turn it off. So you can see here all the steps being cleared. Right. So if you go back to the PB and PL, it's ready to go over again. So you can repeat the same logic for the next round, right? Then let me go back to here for the other two situations. For these two charts, the variations, I'm going to call different subroutines. Okay, so over here, I will call the first variation online edit and variation 1. So this is the logic I post down here. You can see that's the same as here. You can see this, and that's the same part as here. Right. Then let's try that out. Make bigger on here so I can see the output. Here, that's the chart, right? PB1, turn on PL1. When I press PB2, we're going to step 2. PL1 should turn off, PL2 should turn on. So that's what you see exactly. And so on, PB3 and PB4. Then if you go back to the SS, that will clear all the steps again. Same thing for here, for the main routine. If I change to variation 2, with variation 2 and on here, I just need to show you on here on this part, right? So that's the output, then that's the chart. So if you press PB1, you should see PL1 and 3 and 4 turn on. You can see 3 output turn on, except for PL2. Right. Then when you move on to the step 2, by pressing PB2, you should see PL2 and 3 on. Exactly 2 and 3 on, 1 and 4 off. When you go into step 3, you should have 1, 2, 4. 1, 2, 4, and PL3 turn off. When you go into step 4, you should have PL2, 3, 4, 2, 3, 4 turn on, and PL1 turn off. Okay, then you can go back here to clear the steps. Okay, so this is one example I present with PB and PL. So by establish the intermediate logic result, you can combine different steps to get the output you want. Even sometimes the output is very complicated. Right? The other example, right? Toggle switch. Right? The toggle switch logic is a very good example to illustrate programming. All right, so I talked about before. And then I'll have another video to focus on this example. But over here, I just want to use the step logic to design that. Of course, you can design that in different ways. So with this example, we only have one input, a normally open push button called PB, and one output, pilot light called PL. So the logic is that when PB is pressed for the first time, PL is energized. It's a momentary push button, right? So when you press it, you energize. But I want to have the PL remain on after PB is released. So this is the first time. And when the PB is pressed for the second time, the PL should turn off. So even though you press it, but PL turn off. Right? That is the second time. But when the PL press for the third time, the logic repeat as the first time. So that means PL should turn back on, and so on and so forth. Right? So the logic will keep repeating itself. So if you want to use a chart to represent that over here, so we can have step 1, you press the normally open PB. Then you want to turn on the PL. Right? When you release the push button, we can establish that as step 2. That's crucial. Right? At that moment, we have a new step, but the output remain on. We don't want to change output. Right? And step 3 will be the second time. The second time you press the button. When you press the button for the second time, at that moment you want to turn off the PL. Of course, when you release the button for the second time, you're going to step 4, and that will remain 0. And that clear out logic will go back and ready to run that again. So according to the logic, you can see here we have 1, 2, 3, 4 different steps. Sorry, over here, therefore step 4 is here. Right? So that's why you exam off step 4, and when button pressed, you're going to step 1. With step 1 established, you're waiting for button being released. This is press, this is release. At that moment, you're going to step 2. With step 2 established, you're waiting for the button being pressed for the second time. When you press the second time, you're going to step 3. And that just waiting for button being released. Once you release, you're going to step 4. According to the logic, that will clear back all the steps, will repeat. And then you can see with output, we just follow exactly by the chart. Step 1 to turn it on, step 3 turn it off. That's the output with PL. Alright, so let me show you the result here. So I have this button and this pilot light. Let me show you the logic. Okay, so let's look at together on here. At the beginning, everything is 0, right? Nothing is on. So over here is true. It's just waiting for the button being pressed. If I press, this become true. We're going to step 1. But if I hold the button, this will not become true. Right? So it's just waiting for me to release. So I will hold the button so you can see step 1 will be energized, and step 2 is waiting for button being released. Alright, so that's look at here. When I press button, okay, so I should move that screen a little bit. Alright, so but you can see here, step 1 is on, step 2 is off. Right, it's waiting for that. When I release the button, and the logic will go into step 3. Oh no, sorry, not step 3. It just finished step 2. It's here, right? It's waiting for the second time to press. That's what happened with the first time you press and release. Then I'm going to press the button second time. Then that will go into step 3, and so on, going to step 4. But over here you can see that's the step to turn the PL off. So once you go into step 3, PL should turn off. Let's go here. Let's press the button for the second time. PL should turn off. Yes, it turned off. And then When I release the button, you go into step 4, you clear out logic and ready to run again. You can see here it's all being cleared, PL is off, then I can press for the third time. Right? That I'm going to do it very quickly. You can see that logic runs very fast. Here, on, off, on, off, on, off. Okay, so this is the second example with step logic. I will have another video talk about the step logic in subroutines. Alright, so let's just stop here for now.